Hello guys, in this video we'll be learning about concrete encoding of information. In previous videos we discussed how to encode information as a sequence of bits. In this video we turn our attention finding useful physical representation for bits. Our first step is building devices that can process information. If we are going to design a machine that manipulates information, how should the information be physically encoded? So what makes a good bit? Or what properties do we want our physical representation of bits to have? It should be small, it should be inexpensive. We want a lot of bits. So we want a lot of bits. We need some billions of bits, for example, music files, entertainment, social interaction, etc. It should be stable over a long period of time. Once a zero, always a zero. It should be reliable and repeatable. Our representation of bits should make it easy to quickly access and transform, combine, transmit, and store the information they encode. Now, how should we represent bits? We can represent information using electrical phenomena associated with charged particles. The presence of charged particles creates difference in electrical potential energy we can measure as voltage, and flow of charged particles we can measure as currents. We can also encode information using phase and frequency for electromagnetic fields associated with charged particles. The phase and frequency forms the basics for wireless communication. In this course, we'll use voltage to encode information. We'll use the first option, voltage to encode information, but the best choice depends on intended application. We use voltage for encoding information. Let's take an example and see how can we encode information using voltage. We can choose 0 volts to represent logic 0 and 1 volt to represent logic 1. To represent a sequence of bits, we can use multiple voltage measurements or as a sequence of voltages over a time on a single wire. Now let us see the advantages of using voltage for encoding. It is easy generation and detection, potentially low power in steady state, that means low power dissipation in 0 volts where it is connected to ground, and lots of knowledge about voltage. Now let's look into the disadvantages of voltage for encoding. It is easily affected by changing electromagnetic fields in the surrounding environment, DC connectivity, and RNC slows things down. If you want to transmit voltage encoded information, we need to connect it to a wire, and changing the voltage on a wire takes some time because the flow of charged particles is defined by resistance and capacitance of wire. In modern integrated circuits, these RC time constants are small but not zero.